It's February, -20 outside. You wake up to silence. No furnace hum, no fridge buzz, no street lights bleeding through your curtains. The power's been dead for 3 days. You stumble to the bathroom, turn the faucet, and nothing. Not a drip. The pipes froze overnight, and when they thaw, if they thaw, they're going to split like overstuffed sausages and flood your house with water you can't shut off because the main is frozen too. Here's the beautiful irony. 2,000 years ago, the Romans moved billions of gallons of water across freezing mountain passes in Europe, through the Alps, through the Pyrenees, through winters that would make your plumber weep. And those pipes, they didn't burst, they didn't crack. They handled frost, expansion, contraction, and time. And some of them are still functional today. Your PVC pipes are trash, but the Romans built with clay. And today, I'm going to show you why that matters, how it works, and how to make your own terracotta pipes from river mud and fire. No hardware store, no supply chain, just dirt, heat, and physics. Let's start with why modern pipes fail so spectacularly. PVC, polyvinyl chloride, is a plastic. It's cheap, lightweight, and easy to install, which is why it's in every house built after 1970. But plastic has a fatal flaw. It becomes brittle when cold. At around 20 degrees Fahrenheit, PVC starts losing flexibility. At 0, it's stiff as a corpse. And when water freezes inside it, expanding by roughly 9%, the pipe has nowhere to give. It cracks, clean through, sometimes in multiple places. Copper's better, but not immune. It can stretch about 1% before it fails. Ice expansion exceeds that by a factor of 9. So copper pipes survive 1 or 2 freezes, maybe, before they split at the joints or rupture along a weak seam. CPVC, PEX, galvanized steel, they all share the same fundamental problem. They're rigid, they're thin-walled, and they can't handle the physics of freezing water. Now let's talk about what the Romans knew. The Romans didn't have plastic. They didn't have copper wire mass-produced in factories. What they had was clay, fire, and a few thousand years of collective observation. Roman aqueducts, those massive elevated stone channels, get all the attention. But the real engineering genius was underground. Terracotta pipelines called fistulae, buried below the frost line, carrying water across vast distances using nothing but gravity and physics. Terracotta, literally baked earth, is clay that's been fired at high temperatures. What you get is a material that's porous, slightly flexible, and incredibly durable. Unlike PVC, clay can absorb small amounts of moisture. That porosity gives it microscopic breathing room. When water inside expands during a freeze, the clay doesn't fight it. It flexes, it breathes, it yields just enough. More importantly, Roman pipes weren't just clay tubes glued together. They used bell and spigot joints, one end flared, the other tapered, sealed with lead or lime mortar. These joints allowed for movement, thermal expansion, ground settling, minor earthquakes. The system accommodated stress instead of resisting it. When you resist stress, you break. When you absorb it, you endure. The Romans also understood burial depth. Below the frost line, ground temperature stabilizes. In most of Europe, that's about 3 to 4 feet down. In the northern United States, it can be 6 feet or more. The Romans didn't have thermometers, but they had millennia of trial and error. They knew that deep pipes don't freeze because the earth itself acts as insulation. So how does this help you when the grid goes dark and the hardware store is 100 miles of chaos away? You make your own clay pipes. Don't laugh. This isn't some primitive bushcraft fantasy. Terracotta manufacturing is one of the oldest technologies on Earth. People have been making fired clay vessels for at least 20,000 years. The process is straightforward. Find clay, shape it, dry it, fire it. You don't need a kiln. You don't need electricity. You need fire, patience, and a basic understanding of what you're doing. First, you need clay. Real clay, not garden soil. Look near riverbanks, creek beds, or anywhere water has eroded the earth down to dense, sticky sediment. Good clay holds together when wet, and doesn't crumble when dry. Test it. Grab a handful, roll it into a rope, bend the rope into a circle. If it bends without cracking, you've got usable clay. Dig out a few buckets. Remove rocks, roots, and debris. Add water until it's the consistency of thick peanut butter. Workable, moldable, but not sloppy. Let it sit overnight. The water will distribute evenly through the clay body. Now you shape it. For pipes, you need a form. The simplest method is coil building. Roll out long ropes of clay. Spiral them upward around a cylindrical mold. A piece of PVC, a log wrapped in cloth, anything smooth and removable. Smooth the coils together on the inside and outside until you have a continuous tube. Aim for walls about 1/2 inch thick. Thinner and they'll crack. Thicker and they won't fire evenly. For joints, flare one end of each pipe section into a bell shape using your fingers or a rounded tool. The next pipe's narrow end will slot into this bell. When you install them, you'll seal the joint with mud mortar or lime if you've got it. Once shaped, the pipes need to dry. This is critical. Wet clay in a fire will explode, literally. Steam builds up faster than it can escape, and you get ceramic shrapnel. Let your pipes dry in the shade for at least a week. Rotate them daily so they dry evenly. In humid conditions, it may take 2 weeks. When the clay changes from dark to light and feels warm instead of cool to the touch, it's ready. Now, the fire. You don't need a kiln. The Romans didn't always have kilns. What you need is a pit fire, a hole in the ground, a pile of fuel, and 8 to 12 hours of patience. Dig a pit about 2 feet deep and 3 feet across. Line the bottom with a thick layer of dry wood. Hardwood is best. Softwood burns too fast. Place your bone-dry clay pipes on top, leaving space between them for heat circulation. Cover them with more wood, then a layer of dried grass or leaves, then dirt. You're creating a primitive kiln, a contained environment where heat builds slowly and sustains. Light the fire through a small opening at the base. Let it burn hot and long, at least 8 hours, preferably overnight. The goal is to reach about 1600 degrees Fahrenheit, which sounds extreme but is achievable with enough fuel and time. You'll know it's working when the clay glows dull red through gaps in the dirt covering. When it cools, and this takes another full day, dig out your pipes. Tap them gently. Properly fired terracotta rings like a bell. If it thuds, it's underfired. You can refire it or use it for non-critical applications. Now, installation. Bury your clay pipes below the frost line. In most temperate climates, that's 3 feet minimum. Dig a trench, line the bottom with gravel for drainage, and lay your pipes end to end, bell joints facing uphill. Seal the joints with a slurry of clay and lime, or just more wet clay if lime isn't available. Backfill with soil, mounding slightly above grade to prevent water pooling. Connect your system to a water source, a spring, a hand pump well, a rainwater cistern. Use gravity wherever possible. The Romans moved water hundreds of miles without a single electric pump. They just calculated the gradient, a drop of about 1 foot per 1,000 feet, and let physics do the work. Why does this actually work better than modern plumbing? Because terracotta operates on different principles. Modern pipes are sealed systems, airtight, watertight, designed to contain pressure. But sealed systems fail catastrophically. One weak point and the whole line ruptures. Clay pipes are semi-permeable. They breathe. Moisture migrates in and out of the walls slowly, equalizing pressure. When ice forms, the pipe can flex microscopically. When the ground shifts, the joints absorb movement. It's not a brittle sealed tube, it's a resilient system. And here's the dark humor of our situation. The Romans engineered infrastructure meant to last centuries. We engineered infrastructure meant to last until the warranty expires. Roman aqueducts in Spain, France, and Turkey still carry water. Your PVC line won't survive its 3rd winter without a furnace running. One more thing. If you're in a cold climate and the grid dies tomorrow, you don't have time to manufacture clay pipes. Fine. Here's the emergency move. Insulate your existing pipes with what you have. Wrap them in straw, in old clothes, in crumpled newspaper, in literal garbage. The principle is dead air space. Trapped air is one of the best insulators on Earth. Commercial pipe insulation is just foam with air pockets. You can achieve the same effect with layers of dry organic material wrapped and secured with string or wire. For pipes in exterior walls, the most vulnerable, open the cabinet doors beneath sinks to let warm air circulate. Let faucets drip slowly. Moving water resists freezing. Even a trickle can prevent ice dams in your lines. And if they do freeze, don't use a torch. Heating frozen pipes too fast causes rapid steam expansion inside and can rupture the line or start a fire. Use a hairdryer. Use hot water bottles. Use patience. But when spring comes, consider this. The system you depend on failed you. It was designed to fail you. And somewhere in the mud by the river, there's a material that's been solving this problem since before Rome had an emperor. The lesson isn't nostalgia. It's redundancy. Modern systems are optimized for convenience in a world of cheap energy and infinite supply chains. When those assumptions break down, and they will break down, you need fallback options that don't depend on the same fragile infrastructure that failed in the first place. Your great-great-grandchildren probably won't have hardware stores, but they'll have clay. They'll have fire. And if you teach them how to use those things, if you learn how to use them yourself, then you've given them something better than a generator or a stockpile of freeze-dried meals. You've given them knowledge that survives collapse. So when the snow piles up and the power stays dead and your neighbor is dealing with burst pipes and flooded basements, you'll be the one with running water. Not because you're luckier, because you remembered what the Romans knew. Fired earth, gravity, and the stubborn refusal to depend on systems designed to fail.